All right, so welcome to this next Leetcode problem. So this is the search insert position. So given a sorted array of distinct integers, right? So none of the integers will be the same, and a target value, right? So return the index if the target is found. Okay, so in this case, if the target is 5 and it's actually in the array, it's going to return position 0, 1, 2. And if not, return the index where it would be if it were inserted in order. Okay, so in this case, the target is 2 and it's not present in the array, but if it was inserted, it would be inserted into position 1 here, between 1 and 3. Okay. Okay, so let's just snip this. And let's just talk about this problem in Zyport. All right, let's just make this a little bit bigger. Okay, so let's kick off here. Okay, so we have a sorted array and we have a target, right? And we want to find if the target, the position, if the target is in the array, and if it's not in the array, the position that it would slot into. So we have some edge cases, right? So the edge case, the first one is that we can do a check that the target is greater than the last element in the array, and if so, then it's going to be we're just going to return the length of the array, right? That'll give us the position that the target will go into if the target is greater than the last position. And then if the target is less than the first position, we're just going to return 0. So it's just it's going to slot into the very first position. So that's our kind of two edge cases that we can probably get out of the way straight away. So what we can do, obviously, we could just iterate through the array and search for the numbers. So we could just, in this case, we could start in position 0 and go on to position 1 and check if it's equal to target, and go on to position 2 and check that it's equal to target, and if it was, we can just return 2. And also then, for using the same approach, we can look for the target. So we can search. We can iterate through each position. We can search and see if the first element is equal to target. We can also do a check then between the first and the second element, so to check if it's between them. If it is, we can just return that the position we're on plus 1, right? So position plus 1, and we can iterate all the array and do that, and that'll work. But I guess we want that kind of a solution is going to be the order of n, right? So maximum number of elements that might need to be traversed in order to find the target, or else find where the target slots in, will be the maximum number of elements in the array. So that's the max you might have to process. So if we want to bring this down, we can, since it's going to be a sorted array, we can use something like the binary search. So we can search for our target, see if it's which side of the array. If it's not in the middle position of the array, we can either search left or search right. So let's look at what this binary search, how we could solve this using binary search. All right, so let's look at this example first. So the target is 5 and this is our array, right? So what we're going to do first is we're going to get the start position, which is 0, and get the end position, which is 3, right? So we're going to add the start plus the end, which is going to be 3, and we're going to divide that by 2 to get the middle position, right? So the middle is equal to 1 here. So the middle position in this case is going to be 3. Okay, so we're first going to go, okay, is the target equal to 3? Right? And spell tr. Right. If the target is not equal to 3, we are going to check, right? So we're going to check if the target will fit in between the middle item and the item before the middle item. right? And this will make sense now. So if we say if the target is less than the middle plus 1, but minus 1, sorry, if the target is greater than the middle plus mid minus 1, and the target is less than the middle, then we're going to return the middle, right? So we're going to, so if it fits in, so this is better case here, you know, if it fits in between the middle and the middle minus 1, we're just going to return the middle position. So the middle position was 1, right? But if it's going to be inserted, it's going to be inserted into 1. Okay. So that's kind of two scenarios. So this one scenario is we find it straight away in our middle search, and the second one, if it's, you know, if the return position is going to be middle, it's going to be between mid minus 1 and middle. All right. So if it's neither of them, all right. So in this case up here, it's neither of them. We need to decide, okay, you know, which side of the middle are we searching on? Are we searching on the left, or are we searching on the right? So I guess if the target is greater than the middle, so if the target which is 5 is greater than the middle position, we're going to search on right. If the target is less than the middle position, if the target is less than the middle position, we'll search on the left. Okay. So, okay, let's bring this then back into the code. Let's just keep this here, and let's just kick off the code. Okay, so let's put in our edge cases first. So if our target is greater than the last position in the array, the value of the last position in the array, which is length minus 1, we're just going to return the last position in the array that it can get inserted into. So it's going to be nums.length, right? And the other case then is if the target is less than the very first element in the array, we're going to return 0, right? So we're going to turn, it's going to slot into that first 0. Okay, and then if neither of them are satisfied, we're going to return, we're just going to do a binary search, right? So which is going to return either position that the target is in, or the target where the target will slot in. So we're going to pass in the array, we're going to pass in the target, we're going to pass in a start, and we're going to pass it in. So the start will represent the start position in the array we're looking at, and the end position in the array we're looking at. So we're going to look at a certain portion of the array. Okay, so let's just create this function. So we are going to return an int. Let's just declare our array int nums, int target, int start, and int end. So the start position on array is obviously initially it's going to be 0. Alright, so the start position, we know what the array is, we know the length of the array is going to be the last value in the array, so length minus 1. So in our array itself, we are going to get the middle position, right? So first we want to get the middle position, and we want to check if the target is at the middle position. So if we do let's get the middle is equal to start plus end divided by 2, and we just have to put these in parentheses, or the division will get done first. And now we're going to do a check. So we're going to do if the nums in the middle position is equal to the target. Oops. Wait. We're just going to return the target, return the middle. So we're going to return that middle position. The other scenario we talked about is, if it fits in between, so if it's not equal to the middle, the value at the middle, but if it slots into, if it's between the value at the middle -1 and the middle, right? So it's not equal to either of them, but it's between them, and then we're going to return this middle position, right? So if the target is it's greater than nums of middle -1, and the target is less than nums of middle, then we are going to return the middle. Okay, then our next scenario is if we're going to search on either the right or the left, depending on if the target is greater than the middle or less than the middle. So now if the target is greater than nums middle, I'm going to search. So we said if it's greater than middle, we're going to search on the right. And then if target is less than nums middle, we're going to search on the left. Okay. So basically what we're going to do here for each of these is we're just going to recursively call the binary search. So eventually it's going to get to, by moving the position in the array, left or right, and narrowing it down, we're going to get to one of these calls initially. So it's either going to return the position, it's going to return the position if it finds the element, or it's going to return the position that the element should slot into. Okay, so let's just do this. So we're going to pass in the array again, we're going to pass in the target. If the target is greater than the middle, so we're going to search on the right hand side. So the start position now will change to the middle +1, right? So the middle position +1 is where we're going to start, and the end position will stay at the very end of the array that we passed into this method. All right, so we're going to move over to the right, middle +1 to the end of the array. We're going to search then on that side. And then for the case where the target is less than the middle, again we're passing in our array, our target. Our start position is going to be the start position again, right? So the start of the array in this case. And the end position is going to be the middle position and in one -1. Okay. So let's give that a go. Okay, we need a return statement. So just to get this compiling, let's just return 0. Okay, so in this case, we passed in the 1, 3, 5, and 6. The target was, in this case, the target is 2, and it's returning position 1. So it's saying that okay, we couldn't find this target, but if it had to be slotted into the array, it would get slotted in here in position 1, just between 1 and 3. Let's update the test case to 3, 5, and 6, and target is 5. So again, it's found the target 5 in position 2. Let's look at our edge cases of 7. So 7 will be inserted in position 4, right? So 0, 1, 2, 3, and 4. As expected, and then let's put in 0. And 0 is less than the first element, so it's going to be inserted in position 0. And let's do test case then is 1. And the target is 0. And if we pass in this, the 0 will be inserted because it's less than the first element into position 0. All right. Thanks for watching.